Hello all. In this video, we are going to see about the static view of the system components. So this is the static view, and the diagram is similar to the previous hierarchical view of the diagram. You have hardware, operating system, the next layer is system and application program, and the third last layer is called as the user. Okay, next is the dynamic view of the system components. So as I said, the output, the user will give the input to the application software. The application software will in terms request to the OS. The OS will give instruction to the computer hardware. Now if you see in the right side, the computer hardware will processing the result and it will respond back to the operating system. The OS again will respond back to the application software, and the output will be given to the user. So this is the dynamic view of the system components. So what are all the views of an operating system? There are actually three classical views. The first one is called as the resource manager, and second one is called as the control program, and third is the command executor. So if I see as a resource manager, who will manages and allocates the resources, and he has the authority to do this kind of task. And control program, where the which controls the execution of user program and operations of the input output devices. And command executor, which provides an environment for running user commands. One more modern view which we have is called as the virtual machine, which I will explain in the second and third unit. And now we are going to see about the difference between the single processor system and the multiprocessor system. By the name itself, I can say like what is single processor and what is multiprocessor. So it's saying that the single processor system which contains only one processor, whereas the multiprocessor system can contain two or more processors for processing the task. And is there any use of co-processors? There is a use of coprocessor and single processor because it actually uses the multiple controller which are designed to handle special tasks and that can execute limited instruction set. Say for example DMA, direct multiple access controller. Whereas in multiprocessor uses two types of approaches. One approach is called as symmetric and one is called as asymmetric. Multiprocessing, every processor performs all the tasks within the operating system, whereas asymmetric will act as a master and slave. Client and server. What about the throughput of the single processor? The throughput of single processor will comparatively less when we compare to multiprocessor because we are just dumping all the load to the single processor, where your throughput will be somewhat less. Whereas in multiprocessor system you have n number of processor, you can share the process to the multiprocessor system. Okay, here what problem arises in multiprocessor is if suppose a system which contains n processors, then its throughput will be less than n because synchronization must be maintained between two processors, and they also share resources which increase a certain amount of overhead. So in multiprocessor we will have a synchronization problem. And what about the cost of the processor? If I see the cost of a single processor, it is more because here every processor requires separate resources, whereas multiprocessor is less than equivalent multiple single processor system because they use the same resources on the sharing basis. What about the design process of the system? Single processor is very easy to design, whereas multiprocessor system, it has to maintain the synchronization problem. So this was the comparison between single processor and multiprocessor. We should see about the cost, we should see about the design, we should see about the throughput, and we need to what actually the major difference between single processor and multiprocessor. So let me explain the next topic in the upcoming videos. Thank you.